You can see weightage for other subjects also. For civil engineering also, weightage of fluid mechanics is near about same. So around 7 to 9 or 10 marks you can consider for civil engineering also, right. So prerequisite subjects, those will discuss before proceeding to the fluid mechanics. So as you are preparing for fluid mechanics for GATE, so before going for fluid mechanics, you must have knowledge of these subjects. That's what I feel based upon my experience. So engineering mechanics, so in engineering mechanics, mostly you require knowledge from basic concepts such as free body diagram. So in fluid mechanics, at many places will be drawing free body diagrams. So having sound knowledge of concept of free body diagram is very, very helpful while studying fluid mechanics. Apart from that, we'll be using Newton's laws, and kinematics. Yeah, of course, equations of equilibrium also will be using. Equilibrium equations. So equilibrium equations means summation of fx equal to 0, summation of fy equal to 0, summation of moments equal to 0. So those things we are going to use. So this is basics of engineering mechanics. It is required in fluid mechanics. In fact, engineering mechanics is one of the fundamental subjects, and knowledge of engineering mechanics will be very helpful in other subjects like strength of material, machine design, theory of machine. So even though weightage of engineering mechanics is less as compared to other subjects, I highly recommend, based upon my experience, that students should prepare this engineering mechanics thoroughly. Okay. So after engineering mechanics, another subject which we require for studying fluid mechanics is mathematics, and especially from mathematics we require knowledge of calculus, integral calculus, differential calculus. So some students may be weak at mathematics, so I recommend just brush up at least calculus part. At least you should know basic operations like how to find out derivatives, integration, partial derivatives. I am not bothered too much about mathematical meaning of these terms. At least if you are able to calculate calculate derivatives, integration, that will be enough for fluid mechanics. So let us start with our subject. So this is the syllabus for fluid mechanics. By the way, this is not official syllabus. Officially, they will give very few topics, like they will simply mention internal flows, dynamics, only one or two words they will mention. So this syllabus I have decided based upon previous year's questions. Okay. The details of each chapter also will be discussing later on, and those details will be not given in any official syllabus. Okay. So this is based upon my experience, based upon previous year's questions. All right. Before proceeding further, everyone should know that where to put more effort. See, this strategy you can use for any other subject also. So if you want to study any subject, you should understand which chapters are important, and in that chapter which topics are important. See, based upon my understanding, what I think is, it is not essential to complete 100% syllabus for GATE or any other competitive exam. Even if you prepare for 80% of the syllabus, that is good enough. But you should know which 80% syllabus you should prepare. So prepare 80%, it doesn't mean that out of 10 subjects you have to leave 2 subjects. Please never do that. You have to study all the subjects, but in every subject there will be some areas or topics which you can skip, right? So that's why understanding syllabus and understanding important topics from the syllabus, that is very important when you prepare for any subject. So based upon my experience, here I'll give relative weightage of different subjects. So from fluid mechanics, maximum questions will be asked on fluid dynamics and fluid kinematics. So highest weightage I'll give for these 2 chapters, and 5 star means highest weightage. So fluid kinematics, this is also having highest weightage. Of course, for civil engineering, open channel flow, this is also very important. So by the way, this open channel flow, it is not part of mechanical engineering, so only for civil engineering this chapter is there. Then after fluid kinematics and fluid dynamics, the next highest weightage is for internal flow chapter. So actually in internal flow chapter there are 3 subchapters like laminar flow, turbulent flow and flow through pipes. So out of which the weightage of this turbulent flow chapter is very less. So if I want to give, if you want examples from GATE exam, then in last 10 years in mechanical engineering there are only 2 questions on turbulent flow, and in civil engineering there is only 1 question. So weightage is very less. In ESE weightage is little bit more as compared to GATE for this turbulent flow chapter, but still as compared to other topics in internal flow weightage is very less. And while understanding also, this turbulent flow takes lot of effort and nowhere proper theory or content is given related to this turbulent flow. So it is better not to invest too much of your time on this turbulent flow. See, if you want to prepare for any subject, thumb rule is, what I recommend, you should categorize that subject based upon 2 criteria. Whether that subject or topic is really important or not. And second thing is, you should also judge based upon whether that topic is easy to understand or not. Okay. So based upon that, we'll get 4 categories. So first will be, the topic is important also and it is easy to understand also. Second will be, any topic is important but it is not easy to understand, it is little difficult. Third one is, it is not important but easy to understand. And the fourth category will be, it is difficult to understand and it is not important also. Okay. So this fluid turbulence falls into this fourth category. So it is not important exam point of view and it is difficult to understand also. In every subject there will be certain chapters or at least topics which will be falling into this fourth category. So initially you can skip such topics. I am not saying that you should never look at these topics. Initially you can skip. You try to cover at least first category from every subject. So this first category, this is must. You must prepare at least first category from every subject. In every subject there will be few topics on which very frequently question is asked, and those topics will be simple to understand also. Even if you are not interested in that particular subject, you find this category 1 and at least you try to prepare for that. That will be very helpful. See, what I believe is, you should put your effort at a place where there is more reward. There is no point in putting your effort in fourth category, because effort required is also less and reward is also less. But if you put little bit of your effort in first category, you will get better reward. In every subject there will be few areas which will fall into first category. So this you must prepare. And second and third topics, these are recommended. These are recommended. And the fourth one you can keep in option. So this is optional. So if you have time, if you have completed all first 3 categories from all the subjects, then you go to this fourth category, right? But if you leave this turbulent flow, this laminar flow and flow through pipe, these 2 chapters are very easy, and question is also frequently asked based upon laminar flow and flow through pipes chapter. As per me, in fluid mechanics, laminar flow and flow through pipes, these 2 chapters are easiest to understand and easiest to score. There are only few formulas, and in most of the cases you will get direct question based upon formula. So as per me, this laminar flow and flow through pipes, this chapter falls in first category. So you must prepare that. Okay. Then we'll have around 3-star weightage for this fluid statics as well as external flow. So fluid statics is comparatively easier to understand. External flow, it is little bit difficult to understand. In external flow, actually there are 2 sub chapters, boundary layer theory and lift and drag forces. Apart from that, I'll give 2-star weightage to this dimensional analysis and fluid properties. Fluid properties and dimensional analysis, these are easy to understand chapters, especially this dimensional analysis. Here syllabus is very short, mostly you'll get question based upon two laws, that is Reynolds law and Froude's law. So here syllabus is very less and very frequently question is asked based upon those two topics only. So here also you can put your effort. So as per me this falls again in first category, because only one topic. See, overall weightage of this chapter may be less. You may be thinking it is 2-star only. Why I am saying it is falling in first category. Overall weightage of this chapter may be less, but syllabus is also less. So based upon Reynolds law and Froude's law, you will get frequent questions. So if you think in terms of particular topic, then this dimensional analysis is worth to put some effort there. So you can put more effort there because reward is better. This compressible flow, this is recently added chapter. So in last 2 years they have added this. So we can't say anything about this. So for the time being I am giving 1-star weightage, but in last 2 years they have asked, every year they have asked one question. And then the least important is hydraulic machines. So actually what I see is people spend too much of time on these hydraulic machines because there are so many things to study in the hydraulic machines. Actually it is separate subject. Okay? But GATE exam point of view, weightage of that subject is not that much. You have to treat these hydraulic machines as a chapter, not as a subject. And mostly on hydraulic machines you will get theory questions. So 5 out of 10 times you will get theory questions. And sometimes not even 5 out of 10, 6 to 7 out of 10 times you will get theory questions. Around 30 to 40% of the times you will get numerical question. Okay? So don't invest too much of your time on this hydraulic machines also. Now after this, chapter by chapter we are going to discuss each chapter. In every chapter I will tell you what are the topics you have to cover and in which what are important topics, right? Yeah, before that let us discuss little bit about these reference books. So these are the reference books which I recommend, and of course it is not possible to read all those books within limited time, because if you want to read every book thoroughly it will take at least 2 months, right? So this much amount of time you will not have. So how you should approach to these books? Use these books only for reference purpose. Don't read these books line by line. So what I recommend is you have to follow class notes. Class notes will be short and they will be to the point and they will be relevant to your exam. Whereas in books there will be so many things. All the things may not be relevant to your exam. Class notes will be relevant to the exam. So first you follow class notes. If you are able to understand the content from the class notes, no need to go through these books. That is enough. Ultimate aim should be your conceptual understanding. So whichever concepts are required for the exam, if those concepts you are able to understand from the notes, then no need to go through these books. But by chance suppose some of the concepts you are not able to understand from the notes, then you can discuss those concepts with your faculty. Still if you are not satisfied, then same concept you can look in this book. So first two books are a little bit easy to understand. So initially you can prefer these books if you want to read little bit. This Fox and MacDonald, F.M. White, this third and fourth one, these are little mathematical, but they are highly acclaimed books worldwide. So if you feel anything doubtful, like suppose you think something is not correct, whatever your faculty is saying, that may be wrong. If you want to verify something, then this 3 and 4, these are very standard books. You can refer this book number 3 and book number 4. From Indian author books, you can use Som and Biswas and K. Subramanya. This K. Subramanya is especially recommended for hydraulic machines. By K. Subramanya, by this author, there are two books. One is Fluid Mechanics, another is Hydraulic Machines. The Fluid Mechanics book has only theory, whereas hydraulic machine book has theory plus problems. FM book has only theory. What I recommend is, if you are preparing for ESE, this hydraulic machine by K. Subramania is must book, because this is the best available book in the market on this topic, and many times as it is question come in ESE exam from this book. So if you are preparing for ESE, you should read this book. If you are preparing for GATE, then no need to invest too much of your time in this hydraulic machine. Your class notes should be enough for GATE. Apart from these books, if you are having other books like both Moody and Seth, Bansal, these books also you can use for solving problems. But by reading those books, you may feel fluid mechanics little bit difficult, and at some places there may be errors. Okay, so you have to be a little bit careful while using these books. All right. Then we'll discuss our first chapter. So for this first chapter, I gave overall weightage 2 star. But it's not like that. Everything in this chapter is very least important, because 2 star weightage you may tend to think weightage is very less. It's not like that. If you observe few topics like viscosity and non-Newtonian fluids, that is this topic number 3, based upon this topic many times question comes. So I'll give 5 star weightage for this topic. So overall weightage of this chapter is 2 star, but out of which this topic is having 5 star weightage. So from first chapter, if you want to prepare something, you must prepare this topic number 3, and along with that this topic number 4, surface tension. So if you cover these 2 topics, 3 and 4, so you'll be covering around 80% of the questions coming from this chapter, more than 80 in fact. So other topics are having less weightage. So bulk modulus, compressibility, coefficient of volumetric expansion, so 3 star weightage. Basic concepts, 1 star weightage. Vapor pressure, 1 star weightage. Based upon vapor pressure and cavitation, mostly you'll get theory question. The numerical question usually come on topic number 3 and topic number 4. See, this detailed syllabus, it is not given in GATE or ESE. So these details we have decided based upon previous year's questions, right? So similarly, I will go to next topic. In every chapter, we'll see which topics are important. In fluid statics, the overall weightage of this chapter I gave 3 star. So in this chapter, the most important topic is hydrostatic forces on submerged surfaces. Okay. So here I'll give 5 star weightage. This fluid statics chapter, it is comparatively easy to understand as compared to the other chapters. So you can put your more effort here, and in this hydrostatic forces on submerged surfaces, this is most important topic. Here you'll be studying forces on flat as well as curved surface. So usually questions on curved surfaces, these are little bit difficult, but questions on flat surfaces, these are comparatively much easy. So you can put more effort on this topic number 3. So after this questions, you'll get on this 4th topic, which is buoyancy and stability. So buoyancy is one of the simplest topic we can say. There is only one equation, Archimedes principle, buoyancy force equal to rho g into displaced volume. So based upon this equation, you will get many questions. And then stability. In stability of 2 types of objects you have to study. One is completely submerged, another is partially submerged. So based upon this topic also, very frequently question comes, and usually theory question you will get from stability. Pressure measurement. So this is also one of the important topic. And what I see is many students while studying pressure measurement, they study all types of manometer. So they will be putting lot of effort in studying manometer only. Please remember, if you understand any one manometer, other manometers work in similar manner. So you have to just use hydrostatic law along the manometer to find the pressure variation. So don't waste too much of your time while studying different types of manometer and solving so many questions on manometer. In the fluid mechanics, there are so many other things. What I see is students will be involved in studying these simple chapters only. So maximum time they will be studying first chapter and second chapter only. Then next chapters, these are little bit difficult. There they will not put effort. And I also say that unnecessarily students will invest too much of your time in understanding this surface tension phenomena at molecular level. See, what happens at molecular level, no one knows. No need to go into that much detail. Just if you are able to solve the questions, that should be good enough. So initially when students start to study, they will almost try to do research. They will go into too much detail. That is not required. Just look at the level of gate question and ESC question. If you are able to match that level, that means your understanding is good enough. No need to dig into further details. So this thumb rule you can use. Just observe, just try to match gate level and ESC level. If you are able to do that, that is good enough. No need to do further research. So on this hydrostatic law and Pascal's law, few times you will get question, but understanding these two laws is very essential while understanding remaining topics. So this hydrostatic law and Pascal's law, these are used to find pressure variation. So hydrostatic law means change in pressure is rho gh. So this law is called hydrostatic law. And Pascal's law says that pressure at a point is same in all directions. So based upon these two laws, we can visualize pressure variation inside the static fluid. And finding out pressure variation in static fluid is the most important thing. If you are able to visualize pressure in the static fluid, all the concepts are related to the pressure variation only. Pressure measurement, hydrostatic forces, buoyancy, stability, everything is related to the pressure variation. So don't mug up formula, just try to visualize. I have seen many students just try to mug up the formula. But please remember, the visualization is very essential to score good in exams like GATE and ESC. Simply mugging up the formula will not work. Your university exam is different. In your university exam, what you study just before the exam, that matters most. But for exam like GATE and ESC, where you have to study more than 10 subjects, in such case, your conceptual understanding matters. You should be able to visualize various phenomena, like in hydrostatics, how pressure varies, on hydrostatic forces, how this pressure variation is causing the forces. So those things you should be able to visualize. So if you are not good at visualization, I recommend that while studying, you make habit of developing your visualization. That will be very helpful. The next chapter is kinematics. Many students find this kinematics chapter difficult because it is very mathematical. But weightage is very high. Every year you will get at least one question from kinematics. So there are very few chapters in entire syllabus where every year you will get at least one question. So kinematics is one of those chapters from which every year you will get one question. So you cannot afford to skip this chapter. Even though you are not good at mathematics, I recommend at least study something from this chapter. If you at least remember the formula for concepts like continuity equation, for incompressible flow, continuity equation is this one, dou u by dou x plus dou v by dou y plus dou w by dou z equal to 0. So this is continuity equation for incompressible flow. So similar to that, there are various equations. So if you remember the equation and if you know how to perform these mathematical operations like how to find out partial derivative. So if you know that much mathematics, then at least 60 to 70% question you can solve. Okay? So even though you are weak at mathematics, don't skip this. At least try to remember the formula, and based upon formula, you try to solve the question. Around 60 to 70% question will be directly formula based. So if you know the formula and if you know how to perform basic mathematical operation, you will be able to solve such questions. In this chapter, almost everything is important. Still, maximum questions you will get on fluid acceleration. After that, you will get questions on stream function and velocity potential. So after this, you will get almost equal questions on motion of fluid element and basic concepts. So in basic concepts, you have to study Lagrangian and Eulerian approach, various types of flow such as steady, unsteady, uniform, non-uniform, rotational, irrotational, etc. and various lines such as streamline, path line, streak line and so on. Okay. So this detailed syllabus, again I am telling, it is not given in the GATE syllabus, they will only mention few words. So this I am telling based upon previous year questions, right. So everything from this chapter you should prepare, at least formula you should know, and you should know basic mathematical operation. So next chapter is fluid dynamics. So this is also very important chapter. So this also has 5-star weightage. So from this chapter also, every year you will get at least one question. Good thing is, unlike kinematics, it is not that much mathematical. So here there are simple equations like Bernoulli's equation. So everyone knows Bernoulli's equation, P by rho g plus V square by 2g plus Z equal to constant. So based upon this simple equation, you will get maximum questions from this chapter. So the most important topic is Bernoulli's equation. But don't be too much relaxed, because there is wide variety of questions can be asked on the Bernoulli's equation. So some of the questions can be really tough. Okay. So practice thoroughly for this chapter. So this Bernoulli's equation topic, I can say it is falling into the first category. Okay. So till now what I told, here I will make a list for your quick reference. So in first category, laminar flow, flow through pipes, Bernoulli's equation. So these three topics are falling into first category. And in the dimensional analysis, one topic is there, similarity laws. This is simple topic, and based upon this you will get question, and questions will also be simple. Similarity laws. Here you have to study only two laws, Reynolds law and Fruit's law. So this topic is also falling in the first category. So here I will make a list of topic which you must prepare, so that it will be helpful during your preparation. Right. Then next important topic is flow measurement. So this is also simple, and this is also recommended. So this also I will write here, flow measurement. So in flow measurement, we are going to study different discharge measuring devices such as venturimeter, orifice meter, nozzle meter, and velocity measuring device such as pitot tube, Prandtl pitot tube. So if you study topic number 2 and topic number 3, so you will cover almost 50 to 60% question from this fluid dynamics. So these two topics are easy also. Euler's and Navier-Stokes equation, these are little mathematical. I will give 2-star weightage for this. Mostly you get theory question, but nowadays they are asking numerical question on Euler's equation and Navier-Stokes equation. So if you see last 3-4 years GATE paper, in mechanical engineering, this year we got one numerical for 2 marks on Euler's equation, and earlier also there was one numerical question for 1 mark on Euler's equation. So till now there is no question, numerical question on Navier-Stokes equation, but in other papers like XC they are asking. So maybe in mechanical, numerical question on Navier-Stokes equation is expected in the future. This momentum equation topic, this is also important, and this is one of the most difficult topic in entire fluid mechanics, I can say, because nowhere very proper explanation is given. Of course, if you refer standard books like Fox and McDonald, FM White, there these topics are discussed in detail, but approach is little mathematical, so many students find difficult. And there are many misconceptions among students also. related to this momentum equation. So I have seen many students make mistake while applying this momentum equation, especially when we apply momentum equation to the control volume. So tomorrow I am going to take one session on this momentum equation. So if you are weak at momentum equation, please attend. So I will guarantee you that you will gain something from that session. Then angular momentum equation, this is further difficult, but if you know how to use linear momentum equation, you will be able to use angular momentum equation also. Impact object, in case of impact object, no need to use control volume analysis. By simply knowing few basic formulas, you can solve most of the questions on impact object. So this impact object topic, this is easy as compared to first two topics. These are little difficult. So please attend tomorrow's session. I am going to cover linear momentum equation for control volume. So overall weightage of this fluid dynamics is also good, and focus more on topic number 2 and 3. And if you are good at topic number 4, that will be added advantage, because many students will not be able to solve questions from the momentum equation, and in that area you will be able to score. Right. Then we will move to internal flow. So internal flow, this is also one of the most important topic. And as per me, in entire fluid mechanics, this internal flow is the simplest chapter. Of course, turbulent flow is difficult to understand, so don't bother about this turbulent flow right now. If you skip this turbulent flow and if you focus on laminar flow and flow through pipes, these two chapters are one of the most rewarding chapters, you can say. So you have to put less effort, and with less effort you will get maximum reward. For laminar flow through circular pipe, there are only 4 equations. Okay. So I remember only 4 equations. Based upon these 4 equations, I can solve any question. So these equations I am listing here. So for circular pipe, shear stress equation, tau equal to minus dp by dx into r by 2. Why I am listing this equation? Because if you see in books there are lengthy equations given, and equations are, procedure is also mathematical, there are lengthy derivations. So many people feel this chapter little difficult, but if you understand this chapter properly, it is one of the easiest chapter. And here from my experience I am giving the least number of formulas which you should remember, and these are the simplest formula also. So tau equal to minus dp by dx into r by 2, and Newton's law of viscosity minus mu into du by dr. Okay. So here r is the variable measured from center, and when r increases, velocity decreases. As we go away from center, velocity decreases. That's why here minus sign we write. So it is not y, it is r. Then the second equation is equation of velocity profile, u max into 1 minus small r square divided by capital R square. Third equation is relation between average velocity and maximum velocity. So average velocity is half of maximum velocity. And the fourth one is pressure drop equation, 32 mu VL divided by d square. This equation is also called Hagen-Poiseuille equation. So based upon these 4 simple equations, you can solve any question related to the laminar flow through circular pipe. And this is the most important topic in internal flow. Okay. So similar 4 equations you will get for laminar flow between fixed parallel plates. There are similar equations. Now you can find out the similar expression you try to get for laminar flow between 2 fixed parallel plates. So this topic has 4 star weightage. Hydrodynamic entrance length, based upon this topic mostly you will get theory question. So I will give 1 star weightage. On quake flow, nowadays they are asking questions, especially in mechanical engineering. So I will give 3 star weightage. So for this quake flow you have to remember 1 equation, that is enough. So there is one lengthy equation. If you remember that equation, you can solve quake flow. And if you have attended my classes, then in class I told one trick also. So if you know the results for topic number 3. Based upon those results, you can solve any question related to the Kuwait flow also. Okay. But if you don't know that trick, then you should remember one equation, one lengthy equation is there for velocity profile. So using that equation, you can solve any question related to the Kuwait flow. Come to flow through pipes. This flow through pipes, this is also short and sweet chapter. So maximum questions you will get on major loss. So I will give 5-star weightage for this major loss, and for major loss there is only one equation. HF is equal to FLV square divided by twice GD. So based upon this simple and popular equation, you will get maximum questions. So if you see previous year's question, around 40 to 50% questions from flow through pipe, they are asked on major loss. So while using this equation, there is only one difficulty. You have to be a little bit careful about this friction factor, because for different types of flow, expressions for friction factor are different. But again, there is wide variety of questions which can be asked on this major loss, just like Bernoulli's equation. Bernoulli's equation is also simple, but wide range of questions can be asked. So you have to do little bit practice. But still, this is one of the simplest topic we can say, major loss. Then you will get questions on the minor loss. So there are 4 or 5 formulas for minor losses, and then pipe networks. For pipe networks, there are 2 formulas, one for series pipe, another for parallel pipes. So using here one equation, here 4 or 5 equations, here one. Using 6 or 7 equations, you can solve almost any question from flow through pipe. So this flow through pipe and laminar flow, these are the most rewarding chapters in fluid mechanics. Okay. Let us go to next chapter now, external flows. So in external flow, we will be studying boundary layer and lift and drag forces. So this chapter is little bit difficult to understand. Weightage is average, we can say, 3-star weightage I am giving. For civil engineering, weightage is little less. So for civil engineering, you can consider only 2-star weightage. So usually questions are asked more in mechanical engineering on external flow. Maximum questions you will get on topic number 4, solution for boundary layer over a flat plate. So here you have to remember 3 equations. One is expression for boundary layer thickness, another is expression for local skin friction coefficient, and another is expression for average drag coefficient. So maximum questions you will get on topic number 4, and there you have to remember only 3 equations. Of course, 3 for laminar and 3 for turbulent boundary layer. But usually around 70 to 80% questions you will get on turbulent boundary layer. So here you will get 6 equations. Then next important topic is this displacement, momentum and energy thickness. So here you have to remember 3 formulas, one for delta star, another for theta, and another for energy thickness. So usually on this concept, you will get directly straightforward questions. So if you know the formula, you have to substitute the equation, then integrate, you will get answer. Sometimes they ask conceptual questions, but they are very rare. By the way, from boundary layer, if conceptual question comes, then most of the students will not be able to understand, because the concepts of boundary layer theory, those are not discussed properly, especially in Indian author textbooks. So many students find difficulty in getting overall picture about this boundary layer theory chapter. So after this topic, then the next important topic is this lift and drag force. It is having 3-star weightage. So there is one equation for lift force, one equation for drag force, and there is one equation for Stokes law also. So lift coefficient formula, drag coefficient formula, and Stokes law. Fd is equal to 3 pi mu u infinity into d. So based upon these 3 equations, maximum times you will get questions. So on boundary layer separation, mostly you will get theory question. On basics of boundary layer, mostly you will get theory question. Right. So we'll move to now next chapter, dimensional analysis. This is again short and sweet chapter. There are only 2 topics. One is Buckingham pi theorem. So usually on Buckingham pi theorem, conventional question can be asked, because for using Buckingham pi theorem there is systematic procedure. You have to follow certain kind of algorithm to solve for those pi terms. So usually in objective exams like GATE and ESE pre, questions are not directly expected from Buckingham pi theorem, but it's not that they will never be asked. They can ask, such as they will be asking to find out you one of the pi term, but probability of getting objective question on Buckingham pi theorem is less. But of course in conventional exam such as ESE conventional, you can get this question on Buckingham pi theorem. And this chapter, it is not for ESE mechanical, so it is removed from ESE mechanical. It is there in GATE mechanical, and for civil it is there in ESE as well as GATE. The most important topic is similarity law. So I have listed this in first category. So here you have to study only two laws, Reynolds law of similarity and Froude's law of similarity. So Reynolds law is related to the Reynolds number, rho v d divided by mu. Froude's law is related to the Froude's number, v divided by root gel. So you have to match this dimensionless number for model and prototype. So by matching the numbers you will get certain relations. So if you know how to use these numbers, so questions on these laws will be very simple. The only difficulty here is by looking at question you should be able to understand where to use which laws. Okay. So if you follow my class notes, there I have given systematic guidelines where to use which law. So if you are able to understand that, then the procedure to solve questions on these laws will be very easy. The next chapter is hydraulic turbines. In GATE syllabus there are no pumps, there are only turbines. So three turbines you have to study: Pelton turbine, Francis turbine, Kaplan turbine, and similarity laws. So those similarity laws are little different from this dimensionless number. So here there are three similarity laws. One is related to discharge, another is related to speed, and another is related to power. So first law is ND is directly proportional to root H. Law related to the discharge is Q is directly proportional to D square root H, and power is directly proportional to D square into H to the power 3 by 2. So based upon these three equations, maximum questions come from this chapter. So similarity law I will give 4-star weightage. On this hydraulic turbines, so mostly you will get theory question. Around 60 to 70% time you will get theory question, and around 30 to 40% time you will get numerical. So problems will get around 30 to 40% of the time. Usually numericals are also simple. So maximum numerical, out of this 30 to 40%, maximum numerical come on this similarity law. So if you want to see means probability of these questions, then on Pelton turbine, I think in last 10 years there are only 3 to 4 numerical questions. On Francis turbine there are 2 numericals, on Kaplan turbine there is 1 numerical. So 3-star weightage I will give for Pelton turbine, Francis turbine 2-star weightage, and Kaplan turbine 1-star weightage. So mostly you will get theory question as I mentioned, and those questions will be like general knowledge type of question. Which turbine is suitable for high discharge? Which turbine is suitable for high head? Which turbine has high specific speed? Those kind of questions you will get on these turbines. A numerical question mostly you will get on similarity laws. So here just focus more on similarity laws and Pelton turbine. Pelton turbine is easiest to understand also. So just study Pelton turbine and similarity laws and have overall view of Francis and Kaplan turbine. No need to study these things in too much detail, because these are actually subject. This is actually subject. Hydraulic machine is a subject. So if you want to understand all the concept, it will require time. But of course, if you are preparing for ESE, you have to prepare all the topics thoroughly. Now let us come to the last chapter. So this is compressible flow. So this is only for mechanical students, that too in GATE. It is not in ESE. So students from mechanical engineering who are appearing for GATE, they should study this compressible flow. And this is recently added chapter, so we cannot say whether it is very important or not. But in last 2 years, we got one question, once it was simple, once it was little difficult question. So here I cannot say which topic is most important, but I think here, even though they have specifically not mentioned the normal shock waves, the probability of getting question on normal shock wave is little less. So mostly you will get questions on the operation of nozzle. So I am not too much sure about this because this is recently added chapter. So based upon means my guess and gut feeling I am telling this. So basic concepts and isentropic relations, I will give 2-star weightage. See, this compressible flow, it is also a separate subject. So at master's level, we study this compressible flow or gas dynamics as a separate subject. So there are so many things in this chapter. Don't try to go into too much detail because it will consume lot of time. So it's like thermodynamics. Thermodynamics also, if you study, you will feel little bit dry, but if you study thermodynamics 3-4 times, you will get habituated to the thermodynamics and you will feel those topics easy. So if you study this compressible flow for first time, you will feel it difficult. You will not get physical feel of that. But if you keep on studying multiple times, then you may understand few topics there. So what I recommend is just go through the basics. So whatever chapters of this compressible flow which are covered in books like Sengel, that is good enough. Either you see Sengel thermodynamics book or Sengel fluid mechanics book, there will be one chapter on compressible flow. Simply study that chapter, that is good enough for compressible flow. Right. So this finishes your syllabus. So here we discussed where to put more effort and which topics to skip. Okay. So these things we discussed. So 1-star weightage and 2-star weightage means you can put low effort, less effort there. For 5-star and 4-star topics, you can put more effort. Now quickly discuss how you should prepare for fluid mechanics subject. What should be your methodology to study? As I mentioned earlier, don't try to mug up, try to understand the concept. So conceptual understanding is very essential. So what I believe is there are 3 stages of preparation where you must complete, which you must complete to get good rank. So first is conceptual understanding. It means whatever syllabus you have, you should be thorough with concepts, but it is not everything. It is not everything. This is just 40% part of your preparation. Okay. So how to improve your conceptual understanding? So if you are appearing for coaching, just concentrate in the class and try to understand whatever is being taught in the class. Make sure that you understand that concept, how formula comes, which equations are used, what is the logic behind any problem he is solving. You have to think everything logically. Don't try to mug up. Think logically. Try to develop your logic. So this is first part of your preparation. So simply mugging up will not work. So you must be thorough with concept. But that is not everything. This is just 40% part of your preparation. So what I see is many students will be doing this first part only. So most of the times they will be simply studying only. The second important part of your preparation is problem solving. So you should have good problem solving skill. See, understanding some concept is different thing and applying same concept to solve the question is altogether different thing. So I have seen many students can understand the concept, they know the concept, but when it comes to problem, they will not be able to apply that concept to solve the question. So in coaching, you will develop your conceptual understanding part. So if you read the book or if you attend coaching, only first part will be developed. The second part, problem solving skill, you have to develop yourself. There no one is going to help you. So this is your 30% part of your preparation. To improve problem solving skill, you have to solve so many questions. Okay. So for fluid mechanics subject, what I recommend is, once you finish every chapter, suppose you are studying, let us say, fluid kinematics. So once you finish that chapter, you try to solve previous gate question first, because gate questions are good quality questions and there are not mistakes in the questions also. If you take the ESC question, in ESC question sometimes there are mistakes. So you'll get discouraged, whether do you really know the concept or you are missing something. So those kind of things will happen. So first you solve previous gate question. Then if you are preparing for ESC, then you try to solve previous ESC question. And after that, you can try to solve coaching material. But of course, all those things you cannot solve simultaneously, right? So much material is available. There are so many gate question, ESC question, coaching class material. All those questions you cannot solve simultaneously. So how to solve this? That I'll tell while explaining your revision part. And third thing is your paper solving skill. This is the most underrated skill. So as per me, this is having 30% weightage. This is most underrated skill. Only around 4 to 5% students will be focusing on paper solving. Most of the times, around 90% of the times, students will be busy while reading and few students will be busy while solving problems. Very few students will appear for the test series seriously, and only those students will get good rank. This is very underrated skill. I'll tell from my example. So when I appeared for GATE in my final year, I scored 517 rank. Next year, after taking 1 year gap, I scored first rank. The difference between 517 and first rank only was this paper solving. Because when I attempted GATE in final year, at that time I made many mistakes in the paper. So concept I was knowing. I was able to solve questions also. I knew how to solve the questions also. But silly mistake I did in the paper. Next time I just tried to improve that, and that was the difference. So what I believe is 1000 rank student and single digit or double digit rank students, they will not have much difference in their conceptual understanding. All will be at same level. The difference making factor in their rank is this paper solving. The students who get single digit or double digit rank, he is very good at solving paper efficiently. So in limited time, you should get maximum marks. So whatever knowledge you have, from that knowledge you should be able to extract maximum marks in the exam. So that is the aim of this paper solving skill, and this will be improved only after solving so many papers. So what I recommend is, at least you should solve 15 full length papers. And subject wise 2 to 3 at least. 2 to 3 papers. So whenever you complete any subject, so immediately try to give subject wise paper. So while preparing for fluid mechanics, whenever you are preparing for any chapter, just try to focus on concepts. So in fluid mechanics, at many places you will see same thing. Everywhere we are drawing free body diagram and we are applying Newton's law. These things are basic, means it is actually application of mechanics to the fluid only, right? So if you are good at basics, then same thing you can apply everywhere. That will be helpful. Next, study material. Which study material you should have? So first, you should have previous GATE papers. Then you should have previous ESE papers. Then you should have coaching class notes, because these will be to the point and relevant. Then you should have printed material from coaching class, such as classroom practice questions, homework question, because those questions will be designed as per GATE and ESE level. So you can use our ACE Engineering Academy material, especially Bits and Bytes book by ACE Engineering Academy. This is very good. So you'll see good quality questions in Bits and Bytes book. And if you are not having time, then instead of going for Bits and Byte, just solve classroom practice book. Classroom practice book. So in classroom practice book, what we do is we try to cover all variety. We try to cover all variety. Questions will be simple and medium level, but we try to cover all variety. So if you are running out of time, if you want to have a quick revision, so at least you can solve classroom practice question. But if you are having time, then always you should start first with previous GATE questions, then previous ESE question, and then classroom practice questions or any other printed material. So this material you should have. And how to revise? See, many students find difficulty in revising. If you don't study any subject, let us say for 1 month, you will start forgetting many formulas and many concepts also. So just make sure that every month at least you are touching some part of that subject. Okay? So don't keep any subject untouched for more than 1 month. Otherwise, again you have to put more effort while revising that subject. So what you can do is, you can adopt active method of revising the subject. Like I have seen what many students do is, suppose they want to revise, let us say fluid mechanics, they want to revise kinematics chapter. So what they do is, first they will go to notes, they will start reading everything from page 1, or they will go to the reference book and they will start reading from the page 1. Don't do that. You have already studied that subject. So some things you must be knowing, right? So what you do is, suppose you are revising the kinematics. In kinematics there are different concepts like continuity equation, let us say, acceleration, stream function and velocity potential. Let us say these are 3 concepts in the chapter. There are so many other things. For the time being, let us assume there are 3 concepts in the kinematics. Then what you do is, select 10 to 20 different types of question on these topics. 10 to 20 different types of question. So you can select those questions from coaching class material, or you can select those questions from previous ESE questions, or whatever material you have. Select 10 to 20 different objective questions. Don't go for conventional. 10 to 20 different objective questions. And you try to solve those questions without any revision. See, out of let us say 20 questions, if you are able to solve 15 questions, means most of the things you know. So this chapter no need to revise. You are not able to solve 4 or 5 questions, only that part you can revise. Let us say out of 20 questions, you are able to solve only 5. It means you don't know many things. So in such case, just try to understand which are your weak areas. Suppose you are weak at stream function and velocity potential. Just try to reread that concept from first notes. If you are not feeling confident from the notes, then same concept you can read from the reference book. But make sure that you are feeling confident about particular topic. Okay? So in this way, you will reduce lot of your time. Otherwise, what will happen is, most of the times you will be revising the things which you already know. In that way, there will be lot of wastage. Suppose if you are able to solve 15 questions, then immediately you can jump to the next chapter and so on. So this method you can adopt for all the subjects. Then how to prepare for short notes? See, you should not prepare for short notes until you get overall idea about the subject. Overall idea about the subject you will get if you study that subject at least 2 times. Okay? So what I have seen is, many students start preparing short notes immediately after completion of the subject. Don't do that, because you will not come to know what is more important, what is less important. which part you know confidently, which part you are not confident. Those things you will not come to know immediately after completion of the subject. So in that case, I have seen many students start making notes, short notes, and they will start writing everything from the class notes. Then your short notes becomes class notes. There is no point in doing that, right? So prepare that subject once, twice, you will get good idea about that subject. Then you will come to know which are your weak areas, which topics you forget, which formula you forget. Only those things you have to write in short notes. And short notes will be personal. Don't copy short notes from your friends, because your friend may be confident in some topic, you are less confident in that topic, right? So for example, for me this Bernoulli's equation looks simple. P by rho g plus v square by 2g plus z equal to constant. This looks simple. For me, free body diagram application looks simple, but for some students that may be difficult, right? So short notes you should prepare as per your understanding. Just have overall idea about entire subject, and from that whichever thing you think that you will forget, only those things you try to write. Usually in short notes you should write only formulas. Theory part you should not write, except if it is very important and if you think you can forget that. And of course for theoretical subjects like production, there is no way, but you have to write some theory part also, right? But for numerical types of subjects like fluid mechanics, mostly you should write numerical, and no need to write, mostly you should write equations and formula. And no need to write all the equation. For example, if you think that you will never forget this Bernoulli's equation, no need to write this Bernoulli's equation in the short notes. Understand? So how to write test? So this part I will cover quickly. So subject-wise test you should start writing immediately after completion of the test. Suppose you complete fluid mechanics subject now, for 1 or 2 days just revise the subject and try to write the subject-wise test. Full length test, irrespective of your completion of syllabus, you should start full length test from July, not later than July. So many students may think by July syllabus will not be completed. That's true, but don't wait for completion of the syllabus. Okay, even if you complete the syllabus, let us say syllabus is completed in December, still you will feel that I have to do revision. You will never feel confident. Even if you study entire mechanical engineering for 2 or 3 more years, you will never feel confident. So don't wait for completion of syllabus. Start writing test from the July itself. Then you may think, if I write test without completion of syllabus, then I will not get good marks, then I will lose my confidence. Don't worry about that. Let us say up to July you have completed only, let us say, 5 subjects. Okay, we have completed only, let us say, 5 subjects, and these 5 subjects carry, let us say, 30 marks. I am just taking example. Okay. So when you write full length subject, full length paper, then just try to achieve 30 out of 30 marks. Don't bother about remaining 70 marks. Understand? So whichever subjects you have already covered, out of those subjects you should try to get maximum possible marks. That should be aim of your test series. Okay. So out of 30, if you are able to get 25 plus, that means you are on right track. Out of 30, let us say you are getting less than 15 marks, it means something is missing in your methodology of test. Then just do cross checking, means how you can approach the paper better, what kind of mistakes you are doing. And when you write test series now, many things you will come to know. What are your weak areas? So those areas you will not come to know simply by solving the questions at home. Solving question at home is one thing, and solving same question under time pressure is altogether different thing. So what I have observed is, in test series you will be able to solve the questions from the concepts or from the subjects where you are really strong. If you are doubtful about particular topic, those questions you will not be able to solve in the exam. So while writing test series, you will come to know your weak areas also. you will come to know how you should approach for your test. So many things are there. So those things you will come to know only after writing the test. So all the things I cannot explain, so those things you have to experience yourself only. So please start your test series early. From July you can start test series. Initially you can keep little bit more gap also. Like in July you can give only one paper. Then in August you can give one paper. In September you increase number of paper. 2 or 3 papers you give. October again you increase. So gradually you should keep on increasing number of papers. But you should not wait too late for the starting of test series. Like waiting for test series, starting test series in December and January, it will be very late. So here for fluid mechanics I have given you subject wise weightage, and in that topic wise weightage also I have given you. For other subjects you may not be knowing, for that, that's why here I did analysis 2 years back for all subjects. So last 10 years subjects I analyzed, and based upon that I calculated average weightage for each subject, and in that subject I calculated average weightage for each topic also. So for example, for thermal engineering average weightage is 10.8. So this is for GATE, and this is based upon statistical data for last 10 years. So average weightage of thermal engineering is 10.8 marks, and the maximum question you will get on heat work and first law 2.4. So this topic you can say it is a 5-star, something like that. Okay. So I'll just go through the slides, you note down later on. So this will be helpful while preparing other subjects. So this is for our fluid mechanics. Here reference books also I have given for other subjects. This is for theory of machine. Heat transfer. This is for machine design. This is for production. Weightage for production is good. This one is for industrial engineering and operation research. That's it. Thank you guys. I hope your today's session was helpful. Thank you very much.